Hey YouTube, I wanted to make a final video in my, irrigation series videos. I made an irrigation controller video and also a rain gauge video, and I just wanted to make a quick video to show how I'm tying them all together to save some water based on the data that they provide. So I realize this is pretty custom to my individual setup. I'll try and go over it as generically as possible so you can apply some of this logic to your setup. So based on that, this isn't really a step-by-step guide, but more just a resource to hopefully help you create your own logic. I know when I was searching to try and put this together just for my individual setup, I didn't find much data out there. So hopefully this will be useful to you. Before I go into the details of how I set everything up, I just wanted to give you a quick overview of what I'm doing. So if you're not trying to accomplish similar things, you don't have to sit through this whole video just to realize it wasn't useful to you. So the first thing I wanted was to have a switch to activate or deactivate the irrigation if it's not needed. So when it's winter here, I don't have my irrigation turned on, so I don't have that logic running through my home automation system. The other thing I wanted to do was stop the irrigation if it's raining. I wanted to run the irrigation for less time if it's rained in the past 5 days. And I wanted to run either more or less based on the current and past daily average temperatures. And then I wanted to run the irrigation less if it's supposed to rain in the next 2 days. So all of these items up above are designed to help me save water. So for example, I'm using the daily average temperature to know that I need to increase my irrigation at certain times or decrease it if it's been cooler out, because my plants need more or less water based on the average temperature. So if this is of interest to you, I'm going to show you how I set it all up now. Okay, so the things you're going to need, some sort of home automation controller. I'm personally using Vera for all my home automation, so everything is created and coded in that. You're going to need to have some way to monitor the weather. So I'm using the Wonderground app, which is a plugin for Vera, and I'll go into the specifics of that. You're also going to need an irrigation controller. So I'm using my Sensors irrigation controller. You can check out the video I made for that. I'll provide a link in the description of this video for that. I'm also using the My Sensors rain gauge, so I'll also provide a link to the video I made for that. You're going to need to have some way to provide logic or code to execute various functions. I'm using Plague and Lua for that, and I'll go into that later as well. And you're also going to need to have some place to store and load variables. So I'm using the variable container, which is no longer in development, but there's an alternative you can use if you're using Vera called the multi-string app. Okay, so now I'm going to show you how I actually put everything together. I decided to use a separate Plague device to create this logic. So I created an irrigation Plague here. If you've never used Plague before, basically it's a way to do advanced automation in Vera. You can check out my other videos for Plague overview and learning how to use Plague. So I'm not going to go into that, but I'll just show you how I applied it in this specific Plague device. So I created a separate device. The reason for that is I will be able to bypass it during the winter. So instead of doing separate conditions in one of my other Plague devices, I can just bypass it for the winter. Okay, so I'm going to go into my Plague device, and it's actually fairly simple. Most of the logic happens in my actions. I have some pretty custom Lua code in there. So first I'm going to go to my inputs, and I have a couple of different triggers in here. So I have if my drip zones are turned on, and I should just take a step back on that. I have 2 drip zones and the rest are just lawn watering zones. So my drip zones I want to water every 2 days, and my lawn I want to water every 4 days. So I have some custom inputs for my drip zones so I can make sure they're watered every 2 days. I also have a trigger for if all of my irrigation is turned on. So in the irrigation controller, if any of the zones is turned on, there is a default, I guess it's node 0 in the My Sensors device that's turned on no matter which zone is turned on. So this is just an easy way for me to track if the irrigation is turned on. Next I have schedules. So this is the schedules that my irrigation will run. So I have all on, which will run all of my zones. It just turns on that one device and then cycles through each different zone. So Took me a while to figure out which days I wanted to do. It's still not perfect, but I tried to get every 4 days. So I did it every 3rd, 7th, 11th, you get the idea, days of the month. And then my drip runs every 1, 5, 9, and so on. So basically my drip will run every 2 days because it's run in the all on and in the drip on, and then the rest of the zones will only run every 4 days. So I am missing 1 day, it's June 30th, so I will have to go in and manually water it that day if I wanted to get every 4 days. There may be other ways to run it better than what I've done here, but for now this is what I'm using just because it was fairly easy to create a quick schedule. These other ones are used for some of the Lua code for calculating daily temperature averages, things like that. So I'll go into those a little bit more later. So I have 2 device properties here. I have my current rain, so that's based off my rain gauge. So if it's raining, this value will change here, and then it will be over 0. And then I also have here the 5 days rain. So how much rain I've had in the past 5 days. So this is variable 5 of my rain gauge, and then this is the current rain value from my rain gauge. So that's the My Sensors rain gauge that I made, and all those devices will be created if you make one of those devices and add it to your Vera. Okay, so back over to my conditions. Basically, I want to turn off my irrigation if it's raining. So this basically says if it's raining, so if the current rain is not equal to, that's what the exclamation point means, not equal to 0, and the irrigation is on, I'm going to turn it off. So I want to turn off my irrigation if it's raining. Next I have this update runtimes. Notice I have this repeat checks. So this is basically always going to be true, but every time this schedule hits, it will update the runtimes. So I'm updating the runtimes based on that schedule. So I'll go back to this schedule here. So I have update runtimes. If I edit it, I'm choosing to run this at 4:45 a.m. every day. I can change that to anything I want, because what it's going to do is update the runtimes before my irrigation runs. So it would be smart for me to do this before the irrigation runs, so then I can get the most accurate data calculated. So I'm going to show you what the action is for this, but basically what it's going to do is go in and run a big Lua script to pull in past weather data, potential future weather data, and then past rain I've had, past average daily temperatures, and then calculate a percentage of my base run time. So if none of this makes any sense, hopefully as I go on it'll make a little bit more. But anyway, I'm going to update my runtimes at that specific time every day, or if I get any rain, because I want to update my runtimes every time it rains. So I don't want to just run it at 5:45 a.m. and then have a whole bunch of rain at maybe 6 p.m. and then have my irrigation run at 7. I want to have it calculated each time I get a rain update. Okay, then I have this daily temperature increment condition, and this just occurs every time this schedule end of day is true. So I'm going to this schedule here, end of day, and basically at 11:55 p.m. every day it's going to run this, or this schedule will be true, and then it will run the action daily time increment. So this is used specifically for calculating the daily average temperature. I'll go into that a little bit more in detail, but basically the daily average temperature can help indicate how long you want to water, whether it's a garden, a vegetable garden, or lawn. In my research found that basically you want to calculate off of 60 degree, if you're using Fahrenheit, 60 degree days, and then as it gets warmer you want to adjust your irrigation based on that average daily temperature. So anyway, this condition and the action of this condition will write the average daily temperature into, I'm not going to close it now, but into one of my variable containers where it keeps track of those for 5 days. Okay, and then here's my garden drip on, and this will, oh sorry, I missed this one. This turns on my irrigation for 4 days. So this basically when the schedule all on is true, and if it's not raining, it will turn this on. So remember that all on schedule ran every 4 days. And then this garden drip on will run my drip system every 2 days. So I have my S drip on, and if it's not raining. And then my steps drip, this is another drip irrigation, it will run this every 2 days as well, right after my garden drip is finished running. Okay, so hopefully some of that is making some sense. Let's go into the actions now, and I'll explain a little bit more of how this all ties together. Okay, so here we are in the actions. I'm going to go over the basic ones quickly here because they're pretty intuitive, and then I'll go much more in depth into the Lewis scripts and those actions and how they work. So first off, we have garden drip on, which basically turns on my garden drip. Next we have irrigation off, which I'm just going to go up to the advanced here and show you that that just turns the irrigation all zones to target value of 0, which is basically off. And so that would be the same as if I just press that off button in the graphical user interface there where I see all my devices. Okay, so same thing, irrigation 4-day just turns on my all zones, sets it to on, and then my steps drip on will turn on my steps drip zone. Okay, so those are the 4 simple actions for those conditions. Now we'll get into the more complex Lua actions. Okay, so first one I'm going to go into is the daily temp increment. So I'll just click on edit here, and then I'll go to the loop area. So this is where you would put in the script. So I'll make this script available to you. I'll provide a link in the details of this video. So then you would just paste in the code here, then hit Save Lua, then you'd go to Finished, and then obviously save your configuration, so which would cause your Vera to restart. So that's how you would put the loop in here. To actually go over it, I'm going to open up my plague report here, because it'll make it a little bit easier to see everything. So here is the daily temp increment. So what you're going to need is you're going to need your variable ID, which is the device ID of your variable container, where you're going to save in your average IDs, and then you're also going to need the Wonderground app ID. So let me show you where you'll find those now. Okay, so I'm going to go back to my UI5 here, and then I have my Wonderground weather app here. So I'm going to click on the wrench, and then I'm going to go to the advanced tab here, and my device ID is number 45. So that's what I will put into my code here. Okay, then I'm going to go out, and then this is the daily average temp variable container I'm using. So same thing, go to the wrench, go to the advanced tab, and then you can see the number there. So that's what I would put in right up here. Now if you don't have the variable container or the Wonderground app, you can add those by going into, at least on UI5, going to the apps, and then install apps, and then you'd search for them in here. Okay, so going back to the code here, you can leave the SIDs alone. Those should be the same. And then what we're doing here is we are taking whatever was in day 4 and moving it to day 5. So we're just using variables. So we're basically saying get variable 4 and save it into this new variable, or this local variable, day 5, which then in turn will write it down here. So we're saying set variable 5 as day 5. So we're just cascading those down so we're not overwriting anything when we put in the new variables. Okay, so then I'm taking today's high temp, which I'm getting from the Wonderground app, and today's low temp, and then I'm also getting the forecast for tomorrow, which is, this is just the code, so you can leave all this the same. So tomorrow's high temp, tomorrow's low temp, and then I am getting the average of them right here. So I'm getting tomorrow's average, today's average, and then I just write them back into the variable containers, so variable 1 and variable 2. So this is why, if you remember back from my schedule, I'm running at 11, I think 55, because I want this to be as close to the next day as possible. So it's going to get the averages from today and then the average is forecast for tomorrow. So now we're going to move on to the most difficult one to understand. It's got the most code in it, and that is the update runtimes here. So I've got a little description. These are just comments, so this code won't be run. It's just to kind of walk through what's happening. So you can read through that on your own, and then I'll just start explaining the code here. So just like before, we need to put the right device IDs in for our devices. So this is going to be the device ID of the variable container that holds your daily average temperatures. So in my case, it's going to be this one right here, daily average temperature, advanced of 249. Okay, and then we're going to have the baseline ID. So this is going to be the variable container that contains my baseline run times. So this is going to contain the default run times that you want without any adjustments made for daily temperature or rain. And then we have our rain ID, so that's going to be the rain gauge. And then these are going to be the zones, my irrigation zones, so just the IDs of each zone. And then this is my Wonderground app ID here. And then these service IDs, you can leave those alone. Those will be the same for everyone. Okay, so I've got some description in here of what these next two variables do, but basically the degree calc is going to base everything off of 60-degree average temperature day. So if the average temperature exceeds that, it's going to increase the amount of watering, or if it's below that, it's going to decrease it. And then I found that in my research, vegetable gardens need more water than lawns do. So I actually created another calc variable here for my vegetable garden. So this is also based off 60-degree days, but instead it's going to increase it more because I lowered the temperature. So if none of that makes sense, I'm going to show you kind of the equations or the formulas that I used, but you'll need to change these if you are using metric. Okay, next we have some variables that are going to be used in our calculations, and it's in millimeters because that's what my rain gauge is using. So this is the amount of rain in millimeters that will be needed to stop the irrigation. So if I reach 12 millimeters for my drip, it will turn off, and if I reach 25, which is roughly an inch, it will turn it off. So you can adjust that to your needs as well. Okay, so now we're going to start calculating the average temp for the last 5 days. So we're just going to load the average temp variables from our variable container. Then we're going to get a 5-day average and then a 2-day average, which will be used for our drip irrigation. Okay, next we're going to load our baseline watering times from our variable container. So if you had more than 5 zones, you could just create another variable container and then add those in to this code here. Then we're going to load our rain history. So this is going to load the rain history from each of the variables in our rain gauge. So I have my rain gauge, I guess, adding each day on top of the other. So on day 5, it's going to be the total of rain that was received in all of those days. So if I had 5 millimeters on day 1, 5 millimeters on day 2, 0 on 3 and 4, variable 5 would say 10 millimeters because it's just adding up what was in there. So that's the way I have my rain gauge configured. If yours is different, then you're going to have to modify the code slightly, because what I'm doing down here is figuring out the rain for each day. So basically I'm taking whatever's in day 5 minusing day 4 and so on, so I can figure out how much rain was received for that day. Okay, so now I just have a little equation here, or calculation, based on how much rain was received in the last days, and then it's weighted. So I don't want to have, if I received an inch of rain 5 days ago but none since then, I need to water more than if I received an inch of rain yesterday. So basically I just subtracted 20% off of each day. So day 1 is going to be 100%, day 2 is going to be 0.8, day 3 0.6, you get the idea. So all the way down to day 2, even if I had an inch of rain, it would only look like it was 1/5 of an inch. Next, we're going to try and figure out if there's any rain forecast within the next 2 days. If there is, we're going to grab it from the Wonderground app here, and then we're going to add that to our calculation. I didn't want to take that forecast and treat it like it was rain we already received, so I just added it all up and divided it by 2. Obviously, you could change that depending on how accurate your forecast is in your area, but I have pretty localized rain where I live, so they may say it's going to rain in one spot and then a couple of miles away it doesn't rain at all. So I just divided it by 2. It's definitely no scientific calculation, but that way my irrigation will still turn on even if they're predicting a lot of rain. But you can feel free to change that however you see fit. So my Wonderground app tells me rain in inches, but my rain gauge is in millimeters. So then I just need to convert my Wonderground forecast rain into millimeters. So basically I'm just timesing it by 25.4. So if you're using metric, you can comment this line out. Okay, so moving down, I'm just going to convert that rain forecast and the actual rain received into a percentage so I can use it in my equation later on. So basically I'm just adding the forecast rain and the rain that I actually received and dividing it by the rain day 3 calculation or the rain day 5 calculation, and then I'm putting it into the rain 3 day variable so I can use it in my calculation later on. Below that, I'm just going to say if this percentage that I just calculated is greater than 1, I'm just going to make it equal to 1 because I don't want to get a negative number in my calculations. Okay, so next I'm going to take the daily average temperature here, and notice I'm doing this for zone 1 now. So this is the actual time that's going to be saved back into my irrigation zones. So I am calculating that individually for each zone. So I'll show you zone 1 with comments, and then down below it's just the rest of the calculations are made. So first I'm taking my average temperature here and increasing or decreasing my zone 1 time based on the daily average temperature. So here's my zone 1 baseline time, and then I have some calculations here to increase or decrease the time based on the average daily temperature that we calculated up above, and then that's written to zone 1 time. Next I'm going to subtract any rain that we calculated we will receive or have received, and then I'm going to round it to the nearest whole number. So then I just have a calculation. If it's negative, the time we just calculated, then I'm just going to set it to 0, so it won't water at all for zone 1. Okay, then I'm going to set both variable 1 and variable 2 for zone 1 to the value we just calculated. So variable 1 for my irrigation controller is used if I'm using the all zones button, and variable 2 is used if I'm using the single zone button. Okay, now we have a drip zone here. So this is very similar to before. I'm just using 2-day average instead of 5-day and so on. So almost exactly the same code. The one thing I did want to point out further on down here is my vegetable garden drip. So this is where I'm using that additional garden degree calc, so it will increase the runtime more. So if you have a vegetable garden and you want to use my calculations, you would just take the example I have here in zone 4 and use that calculation instead. Okay, so that's pretty much it. I just wanted to take you over to an Excel spreadsheet I made so you could actually see what's going on a little better. So in here I have 11 minutes as my default runtime. Then in here I have my 5-day average temp, so I'm saying it's 80 degrees, and then this is the adjusted runtime based on the 60-degree average. So you can see the equation here, so it would be rounded up to 15 minutes from 11, and then this is the adjusted runtime based on the garden drip. So then if I add in some rain here, so this is just based on my 25 millimeters, so I'm just saying it rained 6, so it's 0.24%. So then it's subtracting that from the total runtime. So it's going to round it back down to 11. And then this standard percent increase was based off of this up here. So if I took out my rain, made it 0, it's going to round it up to 15 minutes if I follow this whole thing down. So the garden drip is not taking into account the rain when I was just using this for my calculations. It's just for the 60-degree average temp. So anyway, I hope that makes a little sense. Basically, all these calculations are going in to either increase or decrease my irrigation based on my default runtime, how much the past temperature's been, and how much rain I've received. So if I increase this, let's say to 18 millimeters, it subtracts that down, so it's only going to run for 4 minutes instead of the default 11. If I change the average degree temperature to 73 degrees, it's going to stay at 4 because the numbers didn't change that much based on the rain. But if I go in here and change that to 8, it subtracted 2 minutes from that. So that's it. I hope that was helpful and you'll be able to take some of my learning and calculations and apply them to your automation, so you'll be able to save yourself some water. In my research, I found that a lot of the irrigation controls were increasing about 30% for the summer, hotter months. So that's pretty much what it's doing here, but it's also taking into account the past rain. So if you see any room for improvement, or if you have any questions, comments, feel free to post them in the comments. Thanks for watching, everyone.